as the movie information is put in by Team 1 into the SQS queue, we have our consumer, which is running on a EC2 instance, which is hosted on Elastic Beanstalk, which is dequeuing this queue and getting the elements. Right now we have a modified version of the consumer running, which is shown on the screen, to see which actors, which movies, and which genres are being populated. So this is the data that is coming up from the queue based on the clickstream that was recorded by Team 1 and put into the queue. So, for example, if you see, you have some movies like Shooters, The Commune, Anastasia, Know That, etc. For the purposes of the demo, we've picked up movies that have drama as one of the genres, and those are some of the movies. And then this is the internal SQS queue that we have right now. We're showing that it has no messages, and this is the initial state. This is the refresh stage with all the messages from the queue processed. So an example message would be looking something like this. It would have the username, the movie name, the genre. Here, the since that movie only has drama, has a genre, it has only one bit set. And this is the lambda function that is defined. The lambda function has a trigger which is used to run once a day, but for the purposes of the demo, we're showing it by running it manually. So to run a lambda function, and before that, I'll also show you the S3 bucket. So this is a list of files that we have already for past days. So when we run the lambda function, it takes a bit to run, and so essentially this is used to flush the contents of the internal queue and consolidate it into a single file in S3, which can then be fed to Spark for the processing. So once that is done, we can see that a new file is getting created there. So this contains all the information, all the clickstream data since the time the last file was created.
So I have started a cluster that runs a Spark job. This Spark job does the clustering and collaborative filtering for the input that for the output. Actually, that's an S3, and gives out a new output that we will see later. So this takes around 8 minutes. So let's actually fast forward to 8 minutes. So the Spark job is running now. Let's see, it should be finished in. Okay, let's refresh it. Yeah, it's running. 36 seconds. It usually takes around 1 minute to run. Yeah, that's because the sample set of users are, I think there are 10 to 11 users for that. The entire collaborative filtering takes 1 minute and should be done by now. So the Spark job has completed. Go steps completed and it's terminating. So the output is, for now demo purpose, it's stored in S3 in the folder called as scalab output filter demo. So these are the outputs. Let's actually download them. Part 1. Okay, let's just see part 1. Yeah, so this output is for a single file output, and this is for a single cluster. We can see that for this user you have the recommendation. This is the first recommendation, this movie is the second recommendation, this movie is the third recommendation. These are sorted according to the ratings that were generated by collaborative filtering, and here we can see two users that are present in this filter. So that's because these two users are more similar to each other and were placed in the same cluster. So that's what we will be giving, or we will be storing to Elasticsearch.